Hey there guys, this is AdamantLife. Welcome to episode 6 of Big Pycture Python, the Python tutorial series where we start out with the big picture and then fill the details in as we need them for our code. So I've made a number of changes again in between the last episode and this one, and this time I'm just going to explain the reasoning behind the changes and what the changes are, and not explain exactly what they're doing or how to write them, because you can always check on the screen and you should be well familiar with this kind of stuff by now. There's nothing actually complicated that I've done, just a couple minor changes. So you should be able to follow along just fine. So previously with equipment, we just had a simple name argument. And unfortunately, if we used Excalibur, for example, Excalibur sword, then we'd be looking up Excalibur in our weight dictionary to get its weight. So we'd have to have all the weapons in our game or in our hero builder or whatever we're making inside the item weights dictionary. To avoid that, we could have done a couple things. We could have just required weight as part of the item definition, but in keeping with how we've been doing things before, I decided just to have all swords, shields, and backpacks weigh the same. So to achieve that, I changed name in item to item name, and name in equipment to equipment name, and then had it pass in an item name as well. So now Excalibur is going to be a sword, which is its item name, and then its equipment name will be Excalibur. If you wanted to, you could just do equip name or any other thing here. Anything you feel like it. Just make sure that you're consistent, obviously. And then to help implement that, I had this function right here to generate the name if it isn't available. So it will take simply the material that the item is made of and the item name to get the equipment name for that item. And that way it will inherit weight and then use the item name to look up the weight. So Excalibur will weigh just as much as, as Zweihander right now, but doesn't really matter. Again, it's one of those things that you can change, or you can add, two-handed sword as an item name, etc. There's plenty of ways to help this work in whatever fashion you want it to work. So you'll have to go through the code and change name to item name in all instances of equipment and items, and then add the equipment name. Now, the other thing that helps us do is for backpacks and swords and shields, that lets us generate the item name by backpack by default. So item name we can just add as backpack or sword or shield down bottom. Secondly, since we're staring at the backpack right now, you will notice that I reverted to using the list. And the reason I did that is because previously we kind of had a situation where we were recording quantities in the backpack as the value to the key. And I wanted to use a dictionary backpack to start out with, just because dictionaries are less intuitive for people. Lists are pretty straightforward and they're easy to grasp, but dictionaries take a little bit more understanding about how they work. So that let us see a whole bunch of different methods and functions that we could use with them. But the fact of the matter is that our items have a quantity associated with them already, so we don't really need that functionality. We can just have the list. Since we changed it to a list, you can just go ahead and basically copy everything, all these special functions, straight out of the dictionary class. And I just changed key to index instead. You literally could just leave it as key and it won't change the functionality at all, because it's just a reference name. And dictionaries and lists use the same format of referencing to get that kind of stuff, so it won't change anything. And then I just added index and remove in here so far. You could also do insert if you wanted to. Additionally, I did add item as a function, so this will take, instead of just taking care of things in append and extend, I'm going to avoid using these for right now. Inside our code, inside of our main program code, and instead just use add item whenever we want to add items to the backpack. And this will check if the item's already in our backpack, and if it is, it will add the quantities together, and if not, it will append the item. So adding quantities together, previously we had add and sub for our adding and subtracting of quantities. And that just returned a number. That's all this is doing here. There should be a return on that line as well. So all this was doing was returning a number. So if we did, candle plus equals another candle, it would actually replace the first candle instance with a number instead of a candle instance. So to rectify that, I added iadd and isub, which functions extremely similarly, but it's going to return the original candle instance at the end. That way, when we do candle plus equals another candle, they will add the second candle will add the quantity to the first candle, and we'll just use the first candle instance to go on with. And up here, obviously, we can just generate basic swords, shields, and backpacks, because we had down bottom that method for generating the name, on the fly by combining the material with the item name. So we should be good to go. Oh, I lied. In the length function, I actually changed this a little bit. So if you look at this format here, first off, I decided to go with the item.quantity for item in self. Okay, so we're just going to get, instead of getting the length of our list, this way if we have 0 candles plus 0 caltrops, instead of having a length on our backpack of 2, we will have a length of 0. And conversely, if we have 10 caltrops, 10 candles, we'll have a length of 20 instead of a length of 2. So this is obviously the more intelligent way to do it. Also, you'll look at this and you'll say, okay, this is a list comprehension, but you forgot your square brackets. As I mentioned when I introduced comprehensions, comprehensions are simply generators, and then we were casting them inside of a list by using the square brackets. So what that means is that you can do it with anything, you can do it with dictionary or anything like that. But what that also means is a generator is an iterable, so we don't even need to cast it as a list first. We can just put it inside a sum, because sum takes an iterable, and then sum will just sum the generator itself. Also, I changed sum item.getWeight instead of going to our get list weight function that we had, because this is just plain cleaner and simpler. So we should be good to go. Now, I believe I told you that we would be spending some time on our other on the actual program section, and I'm gonna have to say I lied. While thinking about it, there's something else that we could be doing right now that we should probably learn that also has to do with modules, because I wanted to do some more work with modules, and that is saving information. So what we're gonna do is we're going to go ahead and import 2 different kinds of data formats. First off, I will start off by saying there is a million ways to save information. You can actually save information in just about any way you can imagine. You just have to have the functions in place to get that information back out and put it back in. But it's always useful to use data formats that are already available, because 1, you don't have to do the footwork to begin with, and 2, if somebody else needs to use your data, then they can easily access it. So we're going to look at 2 different formats, and those are JSON and XML. And we'll be using the eTree as the eTree element tree as the module that we'll be using. XML has a couple different modules that you could use. We'll be using element tree for this one. And we'll be naming it, as last time, to ET, so that we don't have to write xml.etree.elementtree each time we want to use this module. So what I want you to do right now is hop on over to your search engine, search Python JSON, Python XML, and then you can go ahead and pull up the documentation for that. Looking up documentation on your own is a skill that you want to develop, and it will save you time waiting for other people's responses, and some people get annoyed when you ask questions that already have answers on the internet. So you'll want to go ahead and look at that documentation to kind of get an idea. I'll admit the JSON and XML tree documentation isn't the cleanest that I've seen on the Python docs. The Python docs are definitely one of the best documentation that I've seen for languages. Now, granted, my experience with languages is a little bit limited, but I have looked at multiple languages that I haven't necessarily written too much code in. Anyway, all that to say that even though these particular modules aren't the cleanest written, they are still very good documentation to begin with, so you should be able to work through that. Otherwise, I'll be going through it as we use it this episode. So, to start off with, having to create a Jimmy character, the reason we're doing this is because having to create the Jimmy character each time is a bit annoying, and if we start doing stuff in the code, we've got to save the code. Otherwise, we can just save a file and load the file up each time we want to do something. So, we'll be making functions to do this. And there's going to be 3 functions I'm going to make. So it's going to be a save function, a load function, and a serialize function. And a deserialize. There's actually 4. So these are the kinds of functions that we're going to be making today. This one, so we're going to save JSON character. And this will obviously take a character and a file name. So we'll need to know what character we're saving and the file name for where we want to save it. Load. So if we start with JSON character, we just need the file name because the file should tell us everything about the character. Serialize. We're going to take a character, JSON character, and we're actually going to use this as an in-between function for right now. So what we're going to do is we're going to set up JSON serialization functions on the character itself. And then that character will pass us back anything we need to know. And then deserialize JSON character. And this will take a dictionary, because that's what JSON in this case passes us back. It passes us a dictionary. And then we'll break that dictionary down into a character. So, saving a JSON character. What we want to do is we want to take the character and serialize it. I'll say JSON serialize. And we'll go ahead over to the character class and create this function from here. But really quick, I just want to give it a reference. So this is just do dict. And back up here at character, we will define JSON serialize. And we have self. So we're going to start out with a dict, as I mentioned. And there's a couple different ways we could put this dict together. I'm just going to put it together in steps to help keep it clear and easy to read. So we have a number of things. We have basically 2 broad scopes of attributes here for the class. We have object attributes, sword, shield, backpack, and then we have basic type attributes that we can serialize as a normal, which are a dictionary, a list of strings, and a string. So we're going to go ahead and just make overall... we're going to make some lists to reference. That way, if we ever need these lists again, we can just reference them off of this list. So, char basic at equals name, aliases, extra keyword. Char obj at equals sword, shield, backpack. Alright, so I'm going to show you a function that we haven't used yet. It's actually a very popular function in other programming languages because a lot of other programming languages, especially the mainstream ones, are strong typed, which means that you can't just overwrite a variable, a reference, with something completely differently, you've got to recreate that reference with a different type associated with it. So if sword was a null type reference before, because it had none, we would have to recreate sword as a sword typed reference and then assign sword to it. But fortunately with Python, it is not a strongly typed language. So we were able just to replace none directly with sword here. But that's going out of our way to say that it is getters and setters. That's what they're called in other languages. But get attribute, self, and adder, I'm going to say for now. So what this means, the reason we're using this is because this list right here and this list right here obviously are strings, and we need a way to translate those strings into instance attributes. So for adder in char basic at, and then we can get the reference here. Get attribute self adder. So this will translate name. It will look for name as an attribute of the character and get self.name. And then we could say dict adder. So put name into the dictionary. And then it will be equal to the value that we have for self.name, for example. And then self.aliases and self.keywords. And then we can go ahead for adder in char basic at, or char object at rather. And then we will do dict adder equals get attribute self attribute. So we're getting a reference to self.sword, self.shield, self.backpack. And then we're going to go ahead and call their JSON serialize method. And they'll go ahead and do the legwork for us so that we don't have to put code in here in this function. And then we'll just assign that value that they pass us back to dictionary attribute. And then at the end here, we want to return a dictionary. You'll recall that way down here, I had dictionary back from this character.JSON serialize. So to go back up to our items, item is our basic object, so we'll start with that one, off that list anyway. And where do I want to put this? I will put this, actually we'll put this at the bottom because this is kind of a function that's not going to be used too often. Define JSON serialize self return, and I'm going to go ahead and do this one explicitly. So rather than having a list and then iterating over the list, I'm just going to say dictionary item name equals self.item name, quantity equals self.quantity. And there we go. Dictionary item name equals self.item name, quantity equals self.quantity. Super easy. Next, for equipment. So we're going to define JSON serialize self, and then we'll go ahead and do dict equals super, and because we're going to need this stuff that's in here already anyway, so super JSON serialize. So that gives us the basic dictionary, and then we're just going to add our equipment name and material to it. And the way I'm going to do that, I'm going to show you another function that we haven't used yet, filling in the details as we do them for our code, as we say. And the update on a dictionary object is going to take a second dictionary and update our dictionary with it. So if a key is not in our dictionary that's in the second dictionary, it will add it to our dictionary with the value. Otherwise, if the key is already in our dictionary, then it's going to overwrite the value that we have right now and update it with the value that's in the new dictionary. So, equipment name equals self.equipment name, and material equals self.material. You'll notice that I am not going to say underscore dict equals underscore dict.update. That is because there are certain methods, and you're going to have to find this out. For example, append and extend are similar ones that actually return none. And the reason they return none is because they modify the object in place, which they mutate it, which means that it changes already, and it can't be undone, theoretically, but at the same time, it doesn't produce anything new. So if I tried to do underscore dictionary equals this function right here, we would replace our dictionary with none, because all this is returning is none. So that's why we don't reassign dictionary there. And then we will return dict, because those are the only things we needed. We just needed equipment and material out of this thing, because we got the rest of them from the parent. Now, backpack is going to be a little bit different, because backpack has contents. So we will go ahead down at the bottom, where it's out of our way, define JSON serialize. Super JSON serialize dict. So we got that dictionary. That's all stuff that we can use in this class. There's nothing from that dictionary that we don't use in this class. But we also need self.contents. So what we're going to do is dict contents equals, and then we'll go ahead and make this a list comprehension. Item.json serialize for item in self. So we'll just iterate over our items and contents and have each of them serialize themselves for us. That way we don't have to do it ourselves. And we add that to dict and return dict. And that is everything we need to do, because sword and shield will go ahead and just use the default equipment because they function exactly the same. And our item serialize here, we already took care of when we started out with. So we are good to go at this point. So it will go through, it will serialize the sword as an equipment, the shield as an equipment, and then the backpack as equipment plus the contents of the backpack, which are items, which then get serialized. Put it all together and we will have a dictionary with a whole bunch of different dictionaries inside of it. So we are now good to move on. So at this point, we do JSON.dump, and that's going to, actually I gotta back up a little bit. So JSON.dump actually does not take a file name, it takes an actual file object, which we haven't worked with yet because we haven't had to load anything. So the constructor we're going to use for that, or the structure for it rather, is with open. So the with statement takes the function or class afterwards and checks if that has an enter and exit function in it. Double underscore enter, double underscore exit, etc. Just like we do up here with these ones. And if it does, when we open it, or in this case open, but when we enter that function, it will do the enter function, the enter clause. And when we exit, no matter how we exit, whether we exit by error or the program randomly shutting down or whatnot, it will at the very least attempt to do the exit clause. So what happens is if we just did open and then we left the program, that file would be inaccessible because it would still be open in memory. But if we use with open and then the program closes for whatever reason, 99% of the time that file will close. I have not seen with the open function it ever not close, but I'm going to say, that there is probably a chance that in certain situations where your computer completely blows up, that may technically not still close, but that's just one of the risks of it. And if that ever does happen, if you ever end up with a file stuck open, you just go into Python and close the file. You just start up a new script and close it. That's all it takes. And then we will give that a reference as F. F I see most often. File is your other option. Either one works. So with open file name, and this gives us a file object that we can then pass to JSON dumps, that's what it wants. It wants the file object. And then character. Not character, I'm sorry. The dictionary. So we will do this. It will go ahead and write this file for us in JSON format. And we are good to go. So down here, we'll go ahead and take our file name and say let me back up just a second. As I was about to write that next one, I realized that we forgot something right in here. We forgot to pass it an argument, W. So open, by default, opens in a reading mode. W opens in a writing mode. We're going to need to be writing to this file object. So we're going to open it with W, whereas down here we will not pass it an argument because we're just trying to read from it. As F. So really simple, we just load JSON from the dictionary, or from the file into a dictionary. Simple, simple, simple. Now, what do we do with this is the question. Because that's going to come down to how your program is structured. What we probably should do is we should literally just return that dictionary and then deal with this later. And I think that is what we're going to do. In which case, I'm going to come down here and I'm going to take the deserialize out of character and just leave it here. And you'll see why when we get to the next part, why I'm doing this. So now we have the underscore dictionary. We ended up not actually using this one because I went ahead and did it on the character. And then down here in deserialize character, we're going to take that dictionary and turn it back into a character. We'll do a for item in dict, if item in char object attribute, then we're going to need to deserialize that item because into an object. So what I'm going to do here is I'm going to make a translation dictionary. And where do I want to put this? I will put this right here. And this dictionary is going to take a lowercase string, so sword equals sword, and create a reference to the object class. Like that. So it will take this lowercase string and translate it into the class. And I'll go ahead and put item equals item and equipment equals equipment. So I'm going to go ahead actually and create a JSON. We're going to go ahead and save the character really quick. We're going to save Jimmy so that I can show you what a JSON file looks like. It's not actually going to be that impressive. It's just going to look exactly like a dictionary, more or less. But we're just going to get it as a visual reference. So save JSON character Jimmy, and we'll save that to Jimmy.json. Okay, as it turns out, it's been a while since I've used JSON. It actually goes dictionary, then file name. My bad. And then I just opened this up into a different file format, or a different IDE, just so that it would auto-format it for me. Otherwise, it comes out looking just like a long string if you open up the file as itself. But here we go. We have, again, it's a dictionary, so it's in no particular order. We got backpack here as a one of our major items that we're iterating through right now. Shield, sword, extra keywords, aliases, names. That's exactly what we put in, exactly what we got out. So we'll be getting this sword, checking if it's in our character objects dictionary, and then using the trans dictionary to get it back out. So that's where we're at right now. If item in character object attribute. Again, it's useful that we created a list here. That way we didn't have to rewrite it if we had it right here. So let's say we put the list here, we'd have to copy that down, and each time we made changes to the list, we'd have to change it in all places instead of just changing the one place where it's referenced. So if item in there, and then we're going to do item.deserialize. We will do dict item equals item.deserialize. So what we're doing here is we're taking our dictionary and we're taking any items that need to be deserialized and deserializing them. Our name aliases and extra keywords were not special objects and therefore didn't need to be deserialized, so we can just leave them in the dictionary. So per usual, we'll, like we did when we were serializing things, we'll start off with item, use that as the base thing, define deserialize, and I'll put that up here. This is in alphabetical order, and we're going to use the same deserialize function for the XML when we do it. That's why we only have one deserialize function, because we'll be getting a dictionary out of the load XML character. That way we don't need multiple deserialize functions. And we will return item. Actually, this brings up something kind of important. So we're getting a dict passed in here. And I'm going to take this self out. Dict underscore. Alright, so what we're doing here, and this is why we made the translation dictionary back up here, is because I got sidetracked fixing the save function. I totally forgot to explain this one. So trans obj item dot deserialize dictionary. Dictionary item. Alright, now that we've got this all straightened out, let's go over what's going here. So trans object is getting a reference to the item. This item here is going to say sword, shield, backpack right now. Those are the things that are in char object attributes and coming out of our load dictionary. So it's going to take those things and translate them into the class reference. Then we're going to use the deserialize function of the class. Now we haven't done class attributes or class functions yet. They work exactly like instance attributes and functions, but you don't have to pass self because it's not an instance. If it's an instance, it gets self. Otherwise, it's the class. So we're getting a reference to the class, for example, item, using deserialize on that class, and then we're passing it the dictionary that's inside of our dictionary. Again, we've got, if we pop back over here, this is a dictionary inside of our dictionary. You can see the dictionary right there. Dictionary. Actually, it extends all the way down here. My mistake. So it's a dictionary inside of our dictionary. We're taking that inner dictionary and passing it to deserialize so that it can be turned into an object, which we will then replace our dictionary item value with. So if this is dictionary sword, it's getting its value, which is a dictionary right now. So before we start this, dict item is a dictionary, and afterwards dict item is going to be an object, an instance. So that's what we're doing there, just to make sure that we're all on the same page and nobody's getting lost. So in deserialize, we know what our class is. Our class is item. And then we just pass the dictionary to the item constructor. And again, we went over this when we added the double star keywords for equipment, I believe it was. Yeah, double star keywords. So double star takes a dictionary and passes it as keywords to the item class. And that's all we got to do. We just got to return that. So for example, sword has sword as its item name, basic sword as its, actually for Jimmy in particular, he has the Worm Slayer for its equipment name. Its material is bronze, that's going to be in the dictionary. And its quantity is going to be 1 in the dictionary. So we hop down here to equipment, define equipment, deserialize rather. Self, not even self. Define deserialize dict, and we will return. Now I'm not going to super this because this is creating a different item type, a different object type. Equipment underscore dict. So this will work right now with sword and shield as well, but per usual, because backpack is this oddball, we're going to have to overwrite that method with its own method. Define deserialize and underscore dict, and we will return. We will actually first we have to go into if contents in dict. So if we have a key called contents in this dictionary, we have to go into that contents and translate it. So for item in dict contents, because it's going to give us a list of dictionaries, assumably. So for each of those, alright, so we're going to do item in dictionary content. And then this is where we come to a piece of programming code decision points. So at this point, we have to decide to keep this as simple as possible, that only items go into the backpack. Equipment will not go into the backpack. That way we can simply do item for item in dictionary. There are different ways we can get around this. For example, when we JSON serialize, we can add to that dictionary our class. And then we can pop the class out when we deserialize and deserialize it like that. That is one way we can do that to keep to allow us to put equipment and other things in our backpack. But for right now, to keep things simplified, because there's no necessity right now to be putting anything else into our backpack, because we decided a while back that our character would only have 1 sword, 1 shield, and 1 backpack. And he would simply replace the stuff he had with better stuff as he changed. So, to keep things simple, like I said, we're just going to leave it like this. So, now we have our contents as a list of objects. And now we return backpack dict. So this dictionary is a dictionary of keywords, and one of those keywords happens to be a list of objects. And we are good. Our character should now be able to deserialize himself. So return character dict. So this is a dictionary. It is a dictionary with some objects as values, and one of those objects happens to also have objects as values of one within its dictionary, or within its object. And there we go. We have successfully deserialized Jimmy. So what I'm going to do really quick is we'll just go ahead and load JSON character Jimmy. Jimmy.json rather. And that's going to get us a dictionary. So we will say chardict equals load JSON character, and then load character, or a deserialized character is what we call this function. Jimmy equals deserialized character, because that will be returning a character with our deserialized function. And one thing I forgot to add is contents equal none. So kind of like how we did up here in the character, where we had the nuns and then we turned them into objects. We're just going to do that with the backpack. That way the backpack can load contents automatically when it's created, rather than having to set them separately. So if contents none, contents equal list, and then contents equal contents. And we run it. I didn't get any errors, which means that it ran fine. Otherwise, we can just go ahead and print. And we got a character object successfully. So that is JSON. It looks like this episode is running a bit longer, so I think I'm going to save XML for later, for next time. Like I said, we are already set up with the deserialize. We'll just deserialize the XML into a dictionary, and we'll just have to create these two functions next time. So, thank you for watching. Like, favorite, subscribe, as always, and please always comment. It helps a lot. Look forward to next episode where we do XML, and if we have some extra time, I'll go over some other stuff, which I will decide in the meantime. So, have a great, wonderful day, afternoon, or evening, wherever you're at in the world, and I'll catch you later.